Hey, welcome back. This is now 10.2 and we're dealing with rational exponents. That means basically you're going to have some fractions in your exponents, okay? So let's go ahead and make a definition for these things. A to the 1 over n. So in the beginning we won't worry about the numerator. We'll just put a 1 in the numerator and then some integer n, okay? In particular, we say if and we'll say this, call this nth root of a is a real number, and this letter n represent a number that is greater than 2, and it has to be an integer. Then we can connect this rational exponent to this nth root. Okay, so a to the 1 over n is equivalent to the nth root of a, and vice versa. Okay. One technical note: if basically a is, or rather if n is even, a must be non-negative. They say non-negative. It's kind of weird that way. And it's just because you couldn't say a has to be positive, because if you said a has to be positive, that wouldn't include the number 0, because 0 is technically neither positive nor negative. So you have to say non-negative, which is kind of weird, but it's just the way it is. Okay, so anyways, let's take a look at some examples. And basically the directions use radical notation to rewrite and then simplify. As usual, sorry about my handwriting. So let's look. Number 2, 100 to the 1/2 power. Okay, that's just the same as the square root of 100. And again, that number 2, we usually don't put that there for square roots, but if you need to, you can put it there, but it's not necessary. And then the square root of 100 is just 10. What times what is 100? 10. Number 6, negative 81 to the 1/4. Okay, one issue here is you might think, well, I can't do that because negative 81 is negative, but that's not true. The base is actually positive 81. So negative 81 all in parentheses. So in this case, negative 81 would be the whole base to the 1/4. That's not real. But this number here, negative 81 to the 1/4, is, because you could always rewrite it as negative 1 times 81 to the 1/4. Okay, and then you're just thinking negative 4th root of 81, and then that's just going to be negative 3. Okay, number 10, we have 3xy to the 4th raised to the 1/5 power. Not too much you could do with regards to simplifying, but you can rewrite it as a radical, which is kind of what they want. Just rewrite it using radicals. Get rid of the exponent. Okay, so in this case, you're going to have the 5th root of that thing in parentheses. So 3xy to the 4th, and that's pretty much all you can do. Okay. Okay, now we want to generalize this even more, so we want to put something other than just a 1 in the numerator for the rational exponent. So we give you another definition. A to the m over n. Okay. Okay, so again, we need to kind of cross all of our T's and dot all of our I's. We say if the nth root of a represents a real number, also that m over n is a positive rational number that has been reduced. So let me just say positive reduced to lowest terms, no less. So it's a positive reduced rational number. And the n value is greater than or equal to 2, and is an integer, and n is greater than or equal to 2 and an integer. So basically integers are just like counting numbers plus 0 plus the negative counting numbers, except we've restricted it to only be numbers greater than or equal to 2. Counting numbers greater than or equal to 2. If all of that holds, then we can do the following. We could write a to the m over n as parentheses a to the 1 over n times raised to the nth power, and then we can convert that into a radical expression, nth root of a all raised to the nth power. Okay. Likewise, we could rewrite a to the m over n as a to the m raised to the 1 over n, and that will then be the nth root of a to the m. Okay, it kind of follows from what you may remember as back in the rules of exponents, right? So you probably were taught if you have a to the x raised to the y, that's equal to a to the x times y. And that holds here as well. So if you had like a to the 1/5 raised to the 3rd, basically that's a to the 1/5 times 3. And if you multiply those out, you just get a to the 3/5. So what these laws are saying is that you can kind of factor any fractional exponent. So if, for example, if you have a to the 5/7, you could rewrite that as a to the 5th, and then all that raised to the 1/7. Or you could rewrite it as a to the 5/7 as a to the 1/7 raised to the 5th. Okay, so you can factor these exponents and then rewrite them using the rules of exponents. Okay, let's look at some examples of this. And it comes up later on when you're doing certain calculations, and it's quicker to do these in your head than it is to do it on a calculator, because on a calculator to write this expression, it literally takes more work than it does to just do it in your head. So anyways, let's look at this thing. Right, so I have 25 to the 1/2 and then cubed. 25 to the 1/2 is basically the same thing as the square root of 25, and then cube it. Square root of 25 is 5, then cubed is 125. Okay. Let's try 16. Negative 27 to the 2/3. All right, so I could take negative 27 and raise it to the 1/3 and then square that. Okay. So what times what times what is negative 27? That would just be negative 3. And then I got to square that. Negative 3 times negative 3 is just going to be 9. Okay, so usually you want to split up the fraction and the exponent so it makes your life easier, right? So if I had taken 25 to the 3/2 and rewrote it as 25 cubed and then raised to the 1/2 power, that's not going to make a lot of sense for what I need to accomplish in my life, right? 25 cubed, I don't even know what that is, you know. I would have to go to my calculator, and kind of one of the reasons why we learn this is so you don't have to go to your calculator, right? You don't have to get it out, dust it out, turn it on, whatever. Okay, you could just be there with your paper and pen and get the answer. So you want to do this, you know, typically it's this process we are doing, but sometimes you will be called upon to kind of have to do it in the other way. All right. Okay, but just you do the one that's easiest to get away with while doing computations in your head. Okay. Anyways, let's take a look at converting from radical expressions to exponent expressions. So the directions here are to rewrite expressions with rational exponents. And that's all you have to do, right? So 24, we have the cube root of 6. Okay, so that's basically just take 6 to the 1 over 3. Okay. And I mean, literally, you can think of 6 as the same thing as 6 to the 1. And then 6 to the 1, and then you're taking the cube root of it. That's the same as raising it to the 1/3 power. 6 to the 1 is just 6, and then you have to the 1/3. So I get 28. The square root of x to the 5th. Okay. So you can pretend there's a little 2 here. The number on the outside then becomes kind of the denominator in the fraction, and the number on the inside will become the numerator. Okay. So it'll be x to the 5/2. We don't have to worry about the absolute values in this section. If it was ever an issue, they'll even say, assume the variable represents positive numbers, and that just means don't bother with the absolute values, but you'll see that in the directions. Anyways, let's look at this guy. So again, the 7 goes into the denominator in the exponent, and the 5 will go into the numerator. Okay. So actually I miscopied that, so it's like number 32. It's not the same thing. Okay. But anyways, that would be the answer to that problem. Let's look at number 36. And we have the 6th root of something, 9x squared y, and then raised to the 5th power. So basically we just want to take this thing and raise it to some fractional exponent. So we have 9x squared y, and then we're going to raise that whole thing to the 5/6 power. Okay. Anyways, let's now work with negative fractions in the exponents. And you probably remember this from your last algebra class. So if you have a negative in the exponent, what you do is just rewrite it as a fraction. So basically you could drop a to the x to the denominator and change the sign of the exponent. So likewise, 1 over a to the negative x would be just plain old a to the x. Okay. So these are all rules. We have to kind of revisit them now that we have the fractions, and so that's kind of where we are. Anyways, definitions then of a to the negative m over n. And just like I was saying, it's basically this definition here. A to the negative m over n, you're going to drop it to the denominator of the fraction and then change the sign of the exponent. So it's 1 over a to the positive m over n. Right. So let's dive in here and kind of take a look. 81 to the negative 5/4. I'm going to drop it to the denominator and change the sign of the exponent. Then I think I can simplify that using our rules of exponents. So I have 81, I'm going to go 1/4. If I raise 81 to the 5th and then take the 4th root of that, I can't do that in my head, but I can do this in my head. So 81 to the 1/4 is just 3. Okay, and then I have 3 to the 5th. 3 is 9, 3 is 27, 3 is 81, and I think it's 273. 73, 1 over 273. 243, sorry. Try to avoid my calculator, that's what I get. Okay, anyways, let's get 48. So another rules of exponents you may have had if you had one, let's say a over b to the negative x, you could rewrite it as a over b, b over a. So you flip the fraction b over a and then write it to positive x. Okay. That's kind of the same thing we're going to look at in this example. So I have 8 all over 125 raised to the negative 1/3. So I could rewrite that as 125 over 8 raised to the positive 1/3. Then I could take the cube root of that, basically, right? Because that's the same as the cube root of 125 over 8, if you wish. And then that will be 5 over 2. Okay. Let's look at 50. We have negative 8 to the negative 2/3. So first I'll just drop the negative 8 to the denominator. So I have negative 8 now to the positive 2/3. You have to take the whole base along for the ride, so you have to bring the negative down as well. Then I can rewrite the denominator as negative 8 to the 1/3 squared. That'll be 1 all over negative 8 to the 1/3 is negative 2. And then if I square negative 2, I get 4. Okay, so that'll be 1/4. Let's do another 54. 7xz to the negative 1/4. So I can just basically pull the z to the negative 1/4 to the denominator, and that will be about it. So I mean, technically you could rewrite it like this: 1 over z to the positive 1/4. And then if you multiply straight across, so 7x is really 7x over 1. Then 7x times 1 is 7x all over 1 times z to the 1/4. But usually you just go from here to here, and that's fine. Okay, so all of this is kind of hopefully kind of familiar, because it's all centered around these properties of exponents that we had in 095. So we want to revisit those properties to remind you how they work. But of course now within the context of having fractions included in the whole scheme of things. Okay. So properties of these rational exponents. So basically, I'll remind you of what they all were. Basically, we had this product rule. If you have b to the m times b to the n, that's equal to b to the m plus n. Secondly, then you had the quotient rule. If you have b to the m over b to the n, it's the same as b to the m minus n, or you could rewrite it as 1 all over b to the n minus m. Thirdly, b to the m raised to the n. You just multiply the exponents here, m times n. Fourthly, a b to the n. You kind of do is distribute the exponent, so you pretend there's a little 1 on there. So it'll be a to the n times 1 is n, b to the n times 1 is n, so a to the n, b to the n. The fifth ones we think about, a over b to the n is the same. You kind of just distribute the nth power to the a and the b, so it would be a to the n over b to the n. And of course from above we have the kind of the quotient, the negative exponent rules. So if you have b to the negative n, that's the same as 1 over b to the positive n. I guess that should be 6. And then 7, if I have 1 all over b to the negative n, that's equal to b to the positive n. And that kind of a over b to the negative n is the same as b over a raised to the n. Okay. So hopefully those ring a bell somewhere in your past. How do I simplify these things? So the things you want to do, so first you need to make sure you get rid of all the parentheses. Also, you need to eliminate powers to powers. So that would be like number 3 is a power to power. This guy right here. You can't have that. So eliminate powers to powers. And what else? You have to combine all like bases. So bases can only occur once. In particular, this example and this example. You can't have b to some power times b to some other power and then just leave it, because you would have 2 of the same bases, b and b. Okay, so bases can only occur once. And then you want to get rid of negative exponents, usually. Okay, so there are certain instances where it really doesn't matter, but for us, at this point right now, you should be getting rid of them. Okay. Okay, so let's dive right in. Take a look. 56 here. So a lot of this is just practice, practice, practice. And there'll be plenty of homework problems. Okay, so here I have the same base, so I just have to add the exponent. And you just add them like you do in arithmetic. 2/3 plus 1/3 is 3/3. 3/3 is the same as 1. And then that's just 5. Okay, 5 to the first power is 5. Let's look at one with some variables. X to the 3/7 all over x to the 1/7. So I subtract the exponents. 3/7 minus 1/7. That'll be x to the 2/7, and then that'll be it. Okay. Let's look at 66. So power of the power, 3 to the 4/5 raised to the 5th. Multiplying, I have 3 to the 25ths, which is the same as 3 to the 4th. Okay. Then 3 to the 4th. I mean, when reasonable, you want to multiply these out. Okay. So I wouldn't multiply out 3 to the 400th, but 3 to the 4th. If you could do it in your head, do it. Okay. So 3 times 3 is 9, times 3 is 27, times 3, 81. Okay. Some more. Let's look at 68. Y to the negative 3/4 raised to the 1/6. Okay, so I'm going to multiply those out. I get negative 3/4 times 1/6. So 1, 2, let me y. Whoops, I don't want to put the equal sign up there. That looks crazy. Y to the negative 1/8. Okay, and then I hate negative exponents, so I'm going to rewrite it as 1 over y to the 1/8. Okay, 74 is the video quiz question for this video. So I have x to the 1/4 times y to the negative 2/5 raised to the power of 1/3. So first I'm going to multiply the exponents, so I get x to the 1/12, y to the negative 2/15. Then I hate negative exponents, so I'm going to rewrite this as x to the 1/12 all over y and change the sign of the exponent to positive y to the 2/15. Okay. Okay. Let's see if we got anything else. Yeah. So using rational exponents to simplify radical expressions. With these problems, you want to end in radical notation. So sometimes it's not quite clear how they want you to simplify, and you'll see that in the exercises. Just try to go in order with the book and with my notes, and you should be okay. Anyways, using rational exponents, hope I didn't say expressions, exponents to simplify. With a key factoid here about the questions in my math lab. After simplifying in this exercise set, put your answer in radical notation. Okay. Okay, so let's take a look-see at what this is about. Again, we don't have to worry about absolute values. The book will say, presume that all the variables represent non-negative numbers. So, okay. So using the rule of exponents, we can rewrite this as x to the 2/10. Okay. Then that will be the same thing as x to the 1/5 when I simplify. And then what they want you to do is put it back in radical notation. Okay, so it's the 5th root of x to the 1. Of course, we just write x. Clear? Let's do a couple more. 86, the cube root of xy raised to the 21st power. Okay, that'll be the same thing as xy raised to the 21st power divided by 3, which will be the same thing as xy to the 7th. And then putting it in the radical notation, then that will just be the 7th well, I guess there isn't a radical notation for that, right? Because it's a 7, not a 1/7. So I guess the best thing you do is just rewrite it by kind of distributing the power to both terms. Okay. So I guess I should say, if possible, put your answer. So after simplifying, if possible, put your answer in radical notation. Okay. Okay, let's look at one more of these, then we'll look at a harder problem and go on to my math lab. So anyways, here we have the 6th root of ab squared times the cube root of a squared b. Okay. So the first thing I can do is rewrite the a b squared with a 1/6 power, and then I can rewrite the a squared b with a 1/3 power. Then you could distribute those exponents. So I get a to the 1/6, b to the 2/6, which is really 1/3, times a to the 2/3 times b to the 1/3. Then you can combine like bases. So you'll have a to the 1/6 plus 2/3. And then you have b to the 1/3 plus 1/3. Okay. Finding common denominator in the 1/6 and the 2/3. So I need 1/6 plus 4/6 will give me a to the 5/6, and then I have b to the 2/3. Okay, rewriting this with one radical is kind of a little bit challenging, but we can kind of do it if I cheat a little bit by finding a common denominator between these two fractions. So what I'm going to do in that second fraction in the exponent is multiply top and bottom by 2. Okay, and then I'll have a to the 5/6, b to the 4/6, and then I can kind of factor out the 1/6. So this will look weird, but it works. A to the 5th, b to the 4th, raised to the 1/6, and then I could rewrite that as a root, the 6th root. So I'll have the 6th root of a to the 5th, b to the 4th. Okay. Okay, let's look at a little bit of harder one, and then we'll go to my math lab. So 123, I should have made this one the video quiz. Oh well. X to the -5/4, y to the 1/3, all over x to the -3/4, and then raised to the -6th power. Okay. Okay. So at the bat, you can flip that expression if you wish, but likewise you could also just multiply all the exponents by -6, and it's still going to work. Okay. So let's do the other way. So I'll have x to the -6 times -5/4, right? 6 times 5/4, what is that? So 6 over 4 is the same as 3 over 2, so that would be 15 halves. So x to the -15 halves, y to the -6 times 1/3 is -2, and then all over x to the 3/4 times 6. Again, 6 over 4 is the same as 3 over 2. That will be 9 halves. So I'll have positive 9 halves, negative times negative, positive. Then I need to get rid of my negative exponents, and at the same time I need to combine like bases between those x's. So if you drop everything down to the denominator, I think it'll work. So you'll have x to the 9 halves minus -15 halves. Okay. Then I have y to the +2. Okay. So this would be 1 all over 9 halves. Negative now would be plus 15 halves. So that would be 9. Whoops, did I screw that up? My positive 9 halves. Sorry. It seems like I screwed something up. I just can't see it. Oh, it's right here. Negative times a negative is positive. I knew something was weird. Okay, so I'm not going to do that. Then I'm going to bring the denominator one up instead. So sorry. So I'll have x to the 15 halves minus the 9 halves, because what I want to do is end up with positive exponents. And if you pulled it downstairs, it would have ended up turning negative. And of course, I made the mistake when I initially multiplied. Okay, so I end up with x to the 6 halves, which is the same as 3, all over just plain old y squared. Okay, and then that'd be it. All right, let's go into my math lab and see what kind of busyness they have in store for us. And see how ridiculous it gets. Where are you, my math lab? Okay, so I'm just going to go through a whole bunch. You could use it as a reference, or you can watch along if you wish. So here they just want the square root of 169. I think we can handle that. Cube root of 64. It's 4. Rewrite using radical notation. So you're just going to put the 12th root of x times y. So how do I get 12th roots? So you have this little button down here. So you could also go backslash. You could see the little code they give you, backslash nrt. If you literally type that in, you'll get the nth root. So if you go backslash nth root, it'll give you the nth root symbol. This is sometimes quicker. And then xy in here. Make sure it's all inside the radical. Okay, rewrite expression using radical notation. So it's just the cube root. That one's pretty easy. Cube root of 6xy squared. Do we need to? Oh, I'll do it. And it didn't work. And RT. There it goes. Cube root 6xy squared. 16 to the 3 halves is 16 to the 1 half cubed. So it'll be 4 cubed, which of course is 64. Four times 4 is 16. I don't know what I did wrong. What did I do wrong? 16 to the 1 half is 4. Am I going insane? What's wrong with me? Rewrite. Oh, I got to rewrite it with radical notation. Seriously? Do not simplify. Type exact answer. They want radicals. Okay, so it's there's two ways to write it, right? You could write square. So going from here, I can rewrite this as a square root of 16 cubed, or I can write it. If I rewrite this, I could write it as 16 cubed to the 1 half, and then that'll be the square root of 16 cubed. Okay, I think they probably want this answer, but let's see what happens if I put this answer in. See if it still works. Okay, so I got this one's backslash squirt SQ. Well, apparently not. Yeah, it's squirt SQRT 16 and parentheses 2 or 3. It's 3. It's 3. I guess it worked either way. Oh, then they want. Oh, then they want you to simplify. So now you put in 64. Okay, very good. Another one of these. Let's do it right this time. So let's do it the other way around now. So negative 32 to the 4/5. I'm going to rewrite this as the 5th root of negative 32 to the 4th. See how they like that. Just try to break it, you know. And root 5 negative 32 to the 4th. Yeah, I didn't like that. Do not simplify. Type exact answer. Rewrite using radical notation. I guess they want it the other way around. Can't imagine. imagine. Alrighty then, let's get rid of this, and then just put the parentheses around it, and raise it to the 4th power, I guess. I can't imagine that's what they want. That's annoying. Ugh. Oh my gosh. I'm going to have to send them a harshly worded email. Let's see what this one is. I guess they want the way that's easier, because this would be hard to simplify in your head. So maybe that's what they want, the one that's easier to simplify in your head. But then this one is the way we wrote it on the last problem. That wouldn't be. No, I don't want to leave it. Let's just do this first. So this would be -2 if you do the 5th power, the 5th root of it. So -2, and then raised to the 4th power is going to be 2 times 2 is 4, 8, 16. Okay, rewrite using radical notation. So what do we have? The cube root of 125 squared, or it's one or the other. So what do we got? 125 to the 2/3 plus 81 to the 3/4. Okay, so I'm gonna go. I don't know. So I guess 125 to the 1/3, the cube root of 125, which I can do in my head. So I'll presume they want it in that fashion. And then 80 plus 81 to the 4th root of 81 raised to the 3rd power. Try it like that, see what they say. Plus Alright, the cube root of 125 is 5, 5 squared is 25, 4th root of 81 is 3, 3 cubed is 27, adding them together, 2 carry the 152. Rewrite using, use radical notation to rewrite, simplify if possible. Okay, so xy, I guess, squared, the 9th root of that, or the 9th root of xy, and then all of that, the 9th root, Dave, all that squared. It's one or the other. Doesn't make any sense to me which one it is, so I'm trying to answer that question as I go along here. It's 3 to the 1/3. Okay, so we just 22x to the 1/3. X to the 3/2. X to the 7th, y to the 1/3. Okay, this one's a little, oh, that's just 4x y to the 7/3. Okay, so you're going to rewrite it as 1 over 216 to the positive 1/3, and then take the cube root of it So what do they want you to do? Rewrite the expression first, and then probably simplify. So 216 to the 1/3, and then simplify. That'll be 1 all over, is it 6? I don't know, 6 cubed is 216. Same deal here. Let's not even bother with this one. Same deal. Same deal. Okay, let's try this one. Using positive rational exponents, so it should just be 1 all over 6xy to the positive 8/3. Parentheses xy to the positive 8/3. Okay, this one, the z is raised to the, so it would be 6z, or 6, sorry, so it's 6x times 1 all over z to the 1/7, and then you can rewrite that as 6x over z to the 1/7. Properties of exponents. So we're just adding exponents here. So 4 to the 5/5 is just 4. Subtracting exponents, so you get x to the 3/7. X to the 1/7 over x to the 1/3. You want to end up with positive exponents, so you're going to bring the 1/7, x to the 1/7 down, like that. Then find your common denominator. And that should be it. See, so we have a power to a power, so you're multiplying those exponents. So this would be y to the 3 -1 over 21, and then we hate negative exponents, so it would be y to the 1 over 21, 1 over y to the 1 over 21. Okay, 2x to the 1/2 squared. So it's basically the same as 2 squared, which is 4. X to the 2 times 1/2 is just 1, so 4x. And this guy. Okay, so you can kind of distribute the exponent first. So you get x to the 1/10, y to the -7/4, and then we hate the negative exponent, so we write it x to the 1/10 over y to the +7/4. More of that. Okay, use rational exponents to simplify the expression. This is one of those ones where you have to write the answer in radical notation, if possible. Okay, so rewrite this as x to the 2/6, which is the same as x to the 1/3, but you can't write that as your answer because it says write the answer in radical notation. Okay, so you have to rewrite it as cube root of x. Okay, same deal here. 16a to the 12th. So basically 16a to the 12th to the 1/4 power, and then 16 to the 1/4 will be 2. A to the, I'm just distributing this kind of exponent. A to the 12/4 will be a to the 3rd. And then there's no way to rewrite it as a radical. So you're kind of just stuck. This guy, so the 5th root of xy raised to the 20th. So we have, xy raised to the 1/5, and then that thing's raised to the 20th. So you would get xy to the 20 times 1/5 is 4, and then you can't rewrite it anyways. Let's see if they let us put it in parentheses, xy. No, they want you to put it x to the 4th, y to the 4th. So you're going to have to do that. Oops. Kind of jerks. Alright, what's next? Another one of these. So end up being 6y to the 4th raised to the 1/20th. Multiplying out the exponents, you get 6y to the 4/20th, which is 1/5, and then you can rewrite it as a 5th root. Okay. 5th, and then 6y. Okay, more of that malarkey. So this will be 3y to the 1/20th raised to the 12th. So it would be 3y raised to the 12/20th, 12 1/20th. So it's 3/5 raised to the 3/5. So that would be the 5th root of 3y to the 3rd, and I don't know if they'll let you put it like that. So let's go ahead and just get rid of the parentheses, right? So that would be the 5th root of 27y cubed. And more of these guys. X to the 8th, y to the 4th to the 1/20th. This will end up being x to the 8/20th, which will be 2/5, y to the 4/20th, which is 1/5, and then you can kind of think of it as x squared times y to the 1/5, and then you could rewrite that as the 5th root of x squared y. Okay, so square root of 5 times the 5th root of 5. So this is 5 to the 1/2 times 5 to the 1/5. Common denominator, and then add the exponents. They have a like base, but I have to find a common denominator in the exponent. Okay, so this, I need to multiply top and bottom by 5. Here by 2. So that'll be 5 to the 5/10 plus 2/10, which is 7/10. And then you could rewrite that as the 10th root of 5 to the 7. I don't know if they'll let you put it like that, but let's see. And same sort of deal. It'll be x to the 4/9 times x to the 1/2, and you're going to need a common denominator here in the exponent. X to the 18 18th plus 9/18 is x to the 17/18, and then we could rewrite it as the 18th root of x to the 17th. I think we can handle that one. Well, this one looks weird. This would just be the square root of x raised to the 1/7, and then the square root of x you can rewrite as x to the 1/2, and then raised to the 1/7. That'll be x to the 1/14 if you multiply, and then it's the 14th root of x. Then I think you can handle that one then. Okay, sure, let's try it. X to the 7th, y to the 5th, to the 24th. So this is the same as x to the 7th, y to the 5th, to the 1/6, raised to the 24th. 24 times 1/6 is 4. And then you can kind of distribute these exponents to get x to the 28th, y to the 20th. And then it's not possible to put that in radical notation because the exponents aren't fractions. So x to the 28th, y to the 20th. Let's see what we got here. Fourth, and this will be raised to the 1/7 all over ab to the 1/2. That'll be a to the 4/7, b to the 4/7 all over a to the 1/2, b to the 1/2, and then we're just kind of combining stuff together. So a to the 4/7 minus 1/2, b to the 4/7 minus 1/2. Will be a, need a common denominator here. So 8/14 minus 7/14 is 1/14. That'll be b to the 1/14, and they want the answer in radical notation, so the 14th root of a, b, because you could rewrite this thing as a, b to the 1/14. Okay. So 14, and then put a, b in here. Okay, distribute. So be x to the 1/9 minus x to the 2/9. There's really not much anything you can do with that. I guess you could factor out an x to the 1/9 like that, and then you get x minus x squared. I mean, it looks weird, but that works. Oh, no, that would be 1 minus x squared, and then you could get x to the 1/9. Well, that is weird. 1 minus x times 1 plus x. I don't know if they want that, but that would be some craziness if they did, huh? So I don't like this section because it's like that. You don't really know what they want. 1 minus x, 1 plus x. I got positive exponents, buddy. I'm really just not sure. I'm just going to check it again and then see what we get. Really? They just wanted us to distribute, so let me do it again. So similar question. Okay, so you got x to the 1/7 times x to the 2/7 minus x to the 6/7, and if you distribute, you'll get x times x to the 2/7. So you add the exponents, you get x to the 3/7 minus x to the 1/7 plus 6/7 is 7/7, which is just 1. So you just get x to the 3/7. So all you're doing is adding the exponents when you multiply. Minus x. It's a bit silly, but whatever. To the every once in a while you need to be able to do stuff like that. So there it is. Factor out the GCF. Okay, so you get 6x to the 1/8 plus 2x to the 9/8. You could pull out a 2 and x to the 1/8, and you'll have 3 plus x to the I guess 8/8, right, which is 1. So let's see, 2x to the 1/8 times 3 plus x, of course, times 3 plus x. 3 simplifying on steroids. And of course, if you don't see that worked, you can redistribute, and you'll see you're adding exponents on that last one. So x to the 1, so it'd be 2x to the 1/8 times 3 plus 2x to the 1/8 times x, and that would be 6x to the 1/8 plus, and then you have to add the exponents on that second term. So x to the 1/8 plus 1, then you need that common denominator, 6x to the 1/8 plus 2x to the 1/8 plus 8/8, and then you get 6x to the 1/8 plus 2x to the 9/8. Okay, let's look at this one. 81 x to the negative 2 y to the 4th to the negative 1/2 times xy to the 1/2. Okay, let's drop this entire expression to the denominator. So I get xy to the 1/2 all over 81 x to the negative 2 y to the 4th to the positive 1/2. So it'll be x to the 1/2 all over, and then kind of distribute the 1/2s to the expression. So you would get 81 to the 1/2, which is the square root of 81, which is 9. And then x to the negative 2 times 1/2 is negative 1. Y to the 4 times 1/2 is 2. Then I want to move to combine like bases. So I'm going to move the x from the denominator up, and I'll have x to the first power minus the negative 1. So it'll be 1 plus 1. All over 9y squared minus the 1/2 from the numerator. So I'll have x squared all over 9y to the, so 2 is the same as 4 halves, so 9y to the 3 halves. So x squared, oops, x squared divided by y to the 3 halves. So let's take a look at this guy. Okay. I'm going to go ahead and I guess just distribute the negative 20 this time. So the first one would be positive 5/8 times 20. So it'd be 25 halves. Positive y to the negative 25ths is negative 4 all over x to the 3/8 times 20. So this would be 5, 4, so 15 fourths. Right, then I need to get a common denominator. I'm going to go x to the 25 halves minus 15 fourths all over y to the fourth. And so that would be x to the 50 fourths minus 15 fourths, which seems really weird. I don't know. So x to the 35 fourths all over y to the fourth, unless I made some simple arithmetic error because they need to use these weird numbers. X to the 35 fourths all over y to the fourth, and of course. Okay, so I probably made a mistake somewhere. 20 times 5/8. So 4 goes in the 8 2 times, 4 goes in the 25 times, so 25 halves. Negative times negative is positive. Negative 20 over 5 is the same as 4, negative 4. And then 3/8 times 20. So 4 divides 8 2 times, and then so that'd be 15 halves, not fourths. There's a mistake. So I don't need a common denominator, and this will just be x to the 10 halves all over y to the fourth. In other words, x to the fifth over y to the fifths. A little easier. Fifth. Okay, still got a mistake. Fourth. I accidentally wrote fifth. I meant fourth. Third time's a charm. Next, Maroon Islands. Okay, so we have some sort of application. Plant species, in terms of area, how many, it tells you how many plant species you'll have given the number of square miles. So they're giving us 343 square miles for Maroon Island. So that'd be 32 times the third root of 343, whatever that is. To the 1/3 equals 7. $49. No, that's not right. 7 times 32. $224. Another one. Ugh, look at that thing. Part A. Substitute 0 for t. So c of 0. You get 35.74 plus 0.6215 times 0 is just 0, minus 35.74 v to the 4/25 plus 0.4275 times 0 times v. Those should just be 0. Okay, so it'll turn out being c of v, right? So it's in terms of v when you get it, when all is said and done. Okay, so we get 30. So I just plugged in 0 wherever I saw a t. Find c of 45. Find and interpret c of 45. So I presume you're using the c of v equation. C of 45 would be 35.74 minus 35.74 times 45 to the 4/25. Ugh. I already screwed it up. 35.74 minus 35.74 times 45 exponent, where are my exponents, to the parentheses 4 over 25 end parentheses equals something crazy. Round to the nearest degree, so negative 30. Interpret this. So let me reread the question again. V is wind speed. Okay, so I think wind chill. Okay, so when the temperature is 45 degrees Fahrenheit, the wind chill will be, it'll feel like it's negative 30 degrees if your wind speed is 45 miles per hour. Okay, the value of the wind chill temperature is 0 degrees. No. The amount of wind speed needed to make the wind chill temperature equal negative 45 degrees when the air temperature is 0. Yeah, okay. Yeah, so we plugged in 0 for T, and apparently T is temperature. Okay, so yeah, it just seems 45 is the wind speed, 0 is the temperature, and then negative 30 is the chill. So no. Let me read it again. Wind chill temperature can be calculated using the formula below, where C is the wind chill. Okay, so maybe I have to literally sit here and define all these variables. So C is wind chill. T is air temperature. V is wind speed. We presume that T was 0. Okay, so in our case T was 0. Our wind speed is 45 degrees, and that means the wind chill is negative 30 degrees when the wind speed is 45 miles per hour and the air temperature is 0 degrees Fahrenheit. Okay. So what is C of 45? C of 45 is the value of the wind chill when the air temperature is 0 and the wind speed is 45. One more. Sorry about that. You got to read the problem. I'm trying not to read the problem for sake of time. I know I'm getting towards the end here. Identify the solution to part B in the graph shown. The left axis is the wind chill, and so that's the C value, the negative 30. The left axis is the wind chill temperature in degrees Fahrenheit, and then apparently we have airspeed for, I guess, the x-axis is airspeed, and the wind chill is the y-axis. Okay, so 45 comma negative 30 would be down here somewhere. So the solution point is 45 comma negative 30. Oh, and that's it. Okay, well, thank you for watching. If you stuck around, good job. I hope that helped, and we shall see you next time.